The chip design world is undergoing a revolutionary transformation thanks to the power of AI, specifically large language models, LLMs. These AI models are more than just tools for general-purpose applications. They are becoming instrumental in electronic design automation, EDA, where their capabilities are harnessed to solve some of the most complex challenges in semiconductor design. Today, let us further explore how LLMs can change how the semiconductor industry designs chips, from writing hardware description languages to optimizing layouts and enhancing security. One of the groundbreaking uses of LLMs in chip design is the automatic generation of hardware description language, HDL, code, such as Verilog or VHDL. Engineers typically write HDL code to describe how a chip should behave, but LLMs can now assist in generating this code automatically from high-level descriptions. For instance, projects like ChipGPT and RTLLM use LLMs to translate natural language into HDL code, significantly reducing the time spent writing, debugging, and refining code. These models can also ensure the generated code meets performance, power, and area, PPA, requirements, thereby relieving engineers from the burden of manual code generation and ensuring efficient use of their time. AI is also making a significant impact on EDA tools for design optimization. Take ChipNAMO, a domain-adapted LLM, which helps optimize chip layouts by evaluating design choices and recommending refinements. The LLM acts as a reasoning engine, understanding the design constraints and suggesting improvements based on real-time feedback. This automated approach speeds up the design process and helps achieve optimal trade-offs between performance, power, and size, areas traditionally requiring weeks of manual tuning by expert engineers. One area where LLMs genuinely shine is in code verification and bug detection. Complex chip designs require extensive verification to ensure there are no flaws in the logic before fabrication. LLMs like AssertLLM and RTL Fixer are trained to analyze code, detect errors, and suggest fixes. These models can automatically generate verification assertions, conditions that should hold during a chip's operation, helping engineers catch issues early and saving substantial debugging time. Moreover, AI-driven bug detection can enhance hardware security, spotting vulnerabilities that may go unnoticed during traditional verification, thereby reassuring engineers about the safety and integrity of their chip designs. LLMs are also opening up new interaction paradigms between designers and EDA software. For example, ChatEDA allows designers to interact conversationally with their design tools. Engineers can use natural language to ask for design suggestions, clarify specifications, or request optimizations. This interaction model lowers the entry barrier, allowing seasoned engineers and newcomers to engage with the design process more intuitively, thereby empowering a wider range of professionals to participate in the chip design process. As the semiconductor industry enters an era where AI-driven custom chip design is becoming a reality, models like ChipGPT allow engineers to describe custom requirements in everyday language, and the AI takes over the hard work of crafting tailored chips for specific applications, whether for AI accelerators, automotive chips, or even complex photonics. This technology brings unprecedented flexibility, enabling companies to design chips that are finely tuned to their needs without requiring deep expertise in chip design. As AI continues to evolve, its potential to revolutionize chip design will only grow. From writing HDL code to verifying design integrity, optimizing layouts, and even improving hardware security, LLMs are making semiconductor design faster, more efficient, and more accessible. The future of chip design is here, powered by AI.